Design DFA where input is valid if does not contain AAA as a substring. This is a triple A as a substring over alphabet AB. So, solution of the problem, we have to find that the string or input which having not contain a AAA substring. So, solution first is a theory. In theory, we write the definition of a DFA. Definition of DFA. For the definition of DFA and theory regarding the DFA, see my first video of a DFA series. Next point is a logic behind that problem. So here is a input is given. So here is a AA string, but input alphabets is a AB. So input is AB, output is also or every yes no. And states first states is a QS, that is the starting state. Q0 state for A, string contain A. Q1 state for string contain B. So this is a common or always occur in every problem state. So Q0 for A, Q1 for B. Next state is a Q2. We have a substring A. So split here this string A. So for A we take a Q0 state. So forgot it. So then AA. So AA not any state. So AA for Q2. Q2 state for AA. Then for AAA. Q3 for AAA. So these are the states. So here is a we have to find does not contain AAA substring. So we have to not find AAA substring. So final state will be Q0 Q1, which is a final state. Because of Q3 we have to find not contain AAA string. So this is a not a final state because here is a present AAA substring, here is a AA present. That's why this is also not a final state, because when we combine this two state also form a triple A string. So this is a not a final state. So we have does not contain A string. That's why we have only two final state, that is A and B. When we ask here is a it contain, forgot this not does not. Here is suppose here contain AA substring. That time here is a Q3 is a final state, but here is a does not. So here is a Q2 and Q3 that contain a double A or triple A, because a double A here is a combined A, so it form a 3A. That's why that both are not a final state. Final state will be Q0 and Q1. Next point is a implementation. In implementation we draw transition table. In every lecture this is a states, this is a input, here is a, here is a B. This is a transition table, and every lecture I am say to student to go to my previous lecture, because when we clear first previous concepts then go to next concept, because when we directly come on this video not understand anything. Because of that we go to firstly previous or start of the talk playlist, then we understand all concepts. So see first videos from first to last, not here. So we have to understand all concepts. So this is a QS, this is a start state, Q1, Q2, Q3, Q0 is a final state, Q1 is also final state. So this is for understanding I am written here A. So here is a come from A. So we have a state for A, that is a Q0. We take from B have a state that is a Q1. Then we take A having also string, that is a Q2. Then AB having no any state, so we cut A, remaining is a B, state that is a Q1. Then is a BA, so BA having no any state, we cut B, here is A having a state, that is a Q0. Then here is a BB having no any state, we cut here is a B having a state Q1. Then is a upper side A, so here is a Q3 state. Then we go here AAB, so AAB having no any state, cut AB having no any state, cut, then B having a state, that is a Q1. For AAA also A, so here is a Q3 because present, so here present is a A string. Then AAB, so here is also Q3. In the last lecture we say in that contains problem, last state is always same and it is also known as a trap state. So, and here check the merging. So we check for the merge. So QS also is our final state, because it also start state or final state. Because of a we have does not contain problem, so these two are not a final state, remaining will be a final state. Because here is a ask to find AA string, except AAA substring, all states are final state. So these are the final state. So we have a no merging rule. So in merging rule, the final state can be merged, non-final state can be merged with each other. So here is a two state QS and Q1 that having the same states, so both are merged with each other. So this will be merged and QS and Q1 will be merged, and here is a Q1, so Q1 state. So now another transition table is known as a conversion table, because here is a conversion or merging is done, here is known as a final, that is a final, so here is known as transition table. This is a final table, that's why it's called transition table. S input AB, here is that two state are merged, so Q1 is a make a start state and final state, Q0 Q1, then Q0 Q2 Q1, Q2 Q3 Q1 Q3 Q3 Q3. So this is our transition table. So draw transition diagram, Q1 start state and also final state. So Q1 Q0 final state have a double circle, Q3 and here is a Q2. So Q1 to Q0 transition, Q1 to Q1 also transition, Q0 to Q2, Q0 to Q1, Q2 to Q3 transition, Q2 to Q3, Q2 to Q1, Q3 to Q3, Q2 3 Q3. So this is a transition diagram for that problem. So thank you. Please like, share and subscribe my channel.